Okay, sorry about that. Hopefully this will be a little better. Always run into a few technical difficulties. We were discussing students enrolled in Elkhart High School, grades 9, 10, 11, or 12. If we subtract any of these numbers, like say 12 minus 11, we get 1. And 1 has a meaning between grades 11 and 12. That tells you how many years one student is advanced compared to another student. If we did 12 minus 9, that would tell me 3. That would tell me how many years apart there are between freshman year and senior year. So here, the numbers make sense for something that's being measured, and the subtractions make sense. Now, if we go to divide them, like 12 divided by 10, for instance, that doesn't really tell me anything useful. So in this case, our data would be quantitative. We have numbers we can do calculations with, and interval, we have subtractions that make sense. Okay, if we were to measure our body temperatures in Fahrenheit, those of course are numbers that we can do calculations with. We can say like average body temperature is, I think, 98.6. And if we're running 101, that means we have a fever, right? You can do 101 minus 98.6 and tell how many degrees you are too hot, above normal. Similarly, if you get too cold, you can measure how cold you are compared to normal. So here, these are numbers that you would measure. The numbers make sense for calculations. So a quantitative data set. The subtractions make sense again, but in this example, divisions don't make sense for the reason we talked about before. 0 on the Fahrenheit scale is not measuring 0 of something. It's just a position on the scale. So we can't say these are at the ratio level, so we have to stop at interval. Okay. Now, the amount of money in each person's savings account, clearly that's quantitative. You can add, subtract money from your bank account. And those make sense for the bills you pay each month and the money you deposit from income. So we clearly have a quantitative data set here. Now, the questions we need to ask, kind of working backwards, are, can I divide? Do divisions make sense? If I have, say, $10,000 in my bank account and my friend has $5,000, then if I divide those, 10,000 divided by 5,000, you get 2. And you say, well, what does that mean? Does that make any sense? Yeah, it would make sense, right? It would mean that I have twice as much money as my friend, right? 10,000 compared to 5,000. So here, if the divisions make sense, then certainly the subtractions will make sense too. So we're at the ratio level. Okay. Similarly, for the height of each person, if we measured each person's height, we get a number. We can do things with those numbers. We can subtract them. We can divide them. So quantitative. And while it might be rare for someone to be twice as tall as someone else, it's certainly possible. And we don't have to get to twice anyway. It would make sense to say someone's 1.3 times as tall as someone else, or 1.5 times, or 1.1 times. So in this case, like the bank account money, heights of people make sense to divide. So we're also at the ratio level.